This video is rules of exponents. We're going to talk about two rules of exponents, or what we call the first law. Let's start by looking at what each of the laws are. So for instance, all real numbers for x, all real numbers for y, and all real numbers for z work, except x cannot equal 0. This is the same for the second rule here. All real numbers for x, y, and z, but x cannot be 0. Now let's look at the rule. X to the y times x to the z equals x to the y plus z. Notice that the base is the same for both of these. Same thing here. X to the y divided by x to the z equals x to the y minus c. Now let's substitute some numbers in and analyze our first rule. Let's say we have 9 to the third times 9 to the second. Right? What does this really mean? Well, we have the same base here. This doesn't work unless they're both the same base. But 9 to the third is like 9 times 9 times 9. And we're going to multiply that by 9 to the second, or 9 times 9. Well, if you look at this, I really have 5 9s, which gives me 9 to the fifth. Now I'm not going to actually solve this. I'm just going to calculate what my exponent is. So what happened here? I have 3 and 2, and I ended up with 5. So basically, I took my base 9 and I added my exponents. So 9 to the 3 plus 2, or 9 to the 5. So when you're multiplying exponents or powers, you need to add the exponents. Now let's look at division. Let's say I have this example. 7 to the fifth divided by 7 to the second. Let's write this out. That's like 7 times 7 times 7 times 7 times 7, or 5 7s, divided by 7 times 7, or 7 to the second. Now you'll notice here I have 2 pairs of 7s here. Well, we know 7 over the 7 is equal to 1. So these both equal 1. Well, when you multiply something by 1, it leaves it the same number. So in a way, these cancel out, and I'm left with 3 7s, which gives me 7 to the third. So I have my exponent 5 and my exponent 2. I'm going to end up with 3. So when you divide powers, you have 7 to the fifth minus 2. So you subtract your bottom from your top, which will give you 7 to the third. Now let's apply this to some specific problems. It says find the product or quotient. Write your answer using exponents. Now what this means is that you're going to write your final answer using a power. So if I have 6 to the seventh times 6 to the second times 6 to the third, if I use my rule, I'm going to take my exponents and add them. I have all the same base. So 6 to the power of 7 plus 2 plus 8. If I add those up, I get 6 to the 17, and that's my answer. Let's look at the next example. Same base, so I can do it. It follows the rule. It's multiplying, so I'm going to add my exponents, and I'm going to get 10 to the 20th. Simple. Let's look at a couple of division examples. Alright, so I have 11 to the 19th divided by 11 to the 15th. Notice I have the same base number, so I can take 11, I'm going to take my top exponent and subtract the bottom exponent from it. Alright, well, 19 minus 15 gives me 11 to the 4th. And that would be my answer for this one. Let's do one more. Same base, 20 to the 9th, top, minus 7, bottom, gives me 20 to the 2nd, which would be my answer. This is basically what Law 1, or the first two rules of exponents, are. So why don't you apply this to the next set of problems? This is the end of the video on the first law of exponents.